Hello everyone, my name is Alireza. I'm from the University of Alberta, and today I'm going to present our work on migrating from monolithic to serverless architecture. This paper is based on the work that we have done for our industrial partner, ATB Financial, which is a financial institution in Canada. And basically in this work, we explore the migration of a FinTech application with monolithic architecture to a serverless architecture. This is the outline of my presentation. I will start with some background information about the FinTech application that we have used in this study. Then I will discuss the motivation behind the migration to serverless, challenges that we face, the new serverless architecture, and finally, we will have the evaluation of the new system. So let's start with some background information. In banks and financial institutions such as ATB Financial, there are different kinds of documents such as bank statements, balance sheets, letters, and so on. Financial institutions need to read, classify, and extract specific information from these documents and store them in their database. For example, from this example document, they extract 4 different key values, which are file number, borrower, property address, and dimensions. And this is an essential process because a lot of services in banking system rely on the output of this process. These tasks were done manually in the past at financial institutions, so you can imagine how hard it is to do all these tasks manually. So the ATB decided to replace this manual process with a more systematic process that needs less effort. So the solution that they came up with is a document processing system. This system is a replacement for the laborious task of reading, classifying, and extracting information from financial documents. It classifies each document and extracts the text content. Then the output of this system is fed to another system, which is responsible for extracting key value pairs based on the document class. This figure shows the first version of the document processing pipeline with monolithic architecture. Monolithic architecture is a simple way of designing and implementing software system in which all of the components are tightly coupled in a piece of software. As you can see in this figure, this system has 5 main components. PDF to image, it converts each page of a PDF document to an image. Page classifier classifies each page of document to one of the predefined document classes. Pre-processing applies image processing and enhancement techniques to images and make them ready for the OCR component. And finally, the OCR component extracts the text content from each image. And we have also a database that stores the results, which are document, class, and text content. The original system works well for a small number of input documents. However, it cannot handle a large number of documents in a reasonable amount of time. And the only option for scaling the system without changing is vertical scaling by adding more resources to the machine that run the application, which is limited and at some point cannot catch up with the growing demand. So the main motivation for migrating to the serverless architecture is to improve the performance and scalability of the system. I mentioned the word serverless several times, and now let's see what exactly serverless computing is. Serverless is a new paradigm for developing cloud applications and represent the evolution of cloud computing. In serverless computing, despite what its name suggests, we will still have servers that running in the background, but are hidden from you as a user. In this paradigm, cloud providers takes graph infrastructure management and handles tasks such as resource provisioning and scaling. So the developers can focus on the logic of their application. Stateless containers and functions represent the core of this paradigm, and today each of the cloud providers such as Google, IBM, Amazon, and Microsoft have their own serverless platform. In this work, we have used stateless containers in Google Cloud Run platform. Stateless containers are similar to stateless functions in the sense that they are triggered by an event such as an HTTP request. And after completing the job, they disappear and don't save or carry any state information over to the next request. However, using the stateless containers, developers are free to use the programming language and libraries of their choice to write code, which is not the case in a stateless function, in which developers are limited to some specific languages and libraries. Along the migration journey, we faced two main challenges. The first challenge is related to resource limitation of serverless platform. In serverless platform, that in our case is GCP Cloud Run, each instance of Cloud Run service can have up to 2 gigabytes of memory, but the page classifier service needs more than this amount. To deal with this challenge, we split the neural network model into two parts. As you can see in this figure, we have now page classifier 1 and page classifier 2, and we feed the output of last hidden layer in the first part as the input layer to the second part. Second challenge is the high turnaround time of the synchronous HTTP request that services use to communicate with each other. To mitigate this challenge, we used asynchronous HTTP requests instead of synchronous HTTP requests. This figure shows the final architecture of the serverless version. The pipeline starts from PubSub. We send bucket name and the list of document names as a PubSub message to dispatcher service. Dispatcher service sends each document to an instance of coordinator service. The coordinator service plays the role of orchestrator in the pipeline. It breaks the document into pages and execute the pipeline logic on each page. And then it aggregates the results and store them in BigQuery, which is our database. On the right-hand side of the figure, we have page classifier 1, page classifier 2, and OCR services that, thanks to asynchronous HTTP requests in these services are called in parallel for each page. That leads to remarkable speed up in the process. This sequence diagram shows the order of interactions between services in the previous figure more clearly, and it shows the scenario in which we pass one single page document to the pipeline. For the evaluation of new systems and also for training of page classifier, we used RVL CDIP dataset, which is publicly available. It contains about 400,000 document images in 16 different classes, such as letter, form, email, and so on. We stitched the random samples to create a synthetic dataset of PDF documents that have between 7 to 15 pages. We conducted two sets of experiments to evaluate the new architecture. In the first experiment, we compared the serverless architecture with the monolithic in terms of performance and cost by benchmarking both systems on a set of 100 documents that have between 7 to 15 pages. This table shows the results. As you can see, the serverless version is about 93 times faster than monolithic version. And in terms of cost, the monolithic version is about 50% cheaper than serverless version. We also repeated this experiment for the monolithic version on a more powerful virtual machine with 96 virtual CPU and 260 gigabytes of RAM to see to what extent we can improve the performance by adding more resources to the machine that runs the application. But due to sequential nature of the monolithic version, as you can see, adding more resources doesn't improve the performance too much, considering the increase in cost. In the second experiment, we evaluated the performance and scalability of the new system as the number of input documents increases. The x-axis shows the number of input documents, and y-axis is turnaround time. The error bar also shows the 95% confidence interval. As you can see, the turnaround time increases almost linearly, and the reason for this linear increase is that in Cloud Run platform, each service can have up to 1,000 instances simultaneously. So for some services such as Page Classifier 1 and Page Classifier 2, we reach this limit at some point, and this causes next requests to experience a waiting time before getting service. Also, we eliminate the effect of cold start in our experiments by repeating each experiment 3 times, and then we ignore the results for the first iteration, and we consider the mean of result for the second and third iteration. And finally, that's it. Thank you for your attention.
Thank you very much for your talk. Are there any questions?
Yeah, I have one. I asked it in the chat, but I'll ask it again here. So I'm curious if you could talk about your decision to build a neural net with a serverless platform versus like the various managed machine learning products that the various cloud providers have. Were there features you were able to implement, or did you try the performance or cost of those products?
Actually, we have not tried that products, and the reason was that the ATB had a pre-trained model, and they wanted to use the same model without changing anything. So we decided to implement it on serverless.
Yeah. Oh, that sounds like a pretty good reason, actually. Yeah. Yeah.
All right, so I also have a question. So if you can go back one slide to your results.
Okay. Yeah.
So we were talking a lot about variability in this workshop, and I see here something that looks like a trend. So the more documents you have, the more variability you introduce in your.
Right.
Do you have any idea why that is?
I think the reason is that as we increase the number of documents, the waiting time, also the number of errors that we get because of the system already reached the limit of instances will increase. So it can be the result for the variability as increase in variability as the number of input document increases.
Mm-hmm. I see. Are there any other questions?
Hi, yes. So I wanted to ask, you've talked quite a bit about the performance side of using serverless. What's your experience with the development experience? Was this easier than developing a monolith, harder? What do you think about maintaining the
Uh,
application?
Actually, the hardest part in developing of serverless architecture was debugging, because every time you have to containerize your implementation and deploy it on the cloud run, and then see the logs to see, for example, what errors or problems you have. I think the hardest part was debugging.
So the increased time that the feedback loop takes, where you build new code, and then in order to evaluate it, this takes a minute or two, right?
Right.